Hello, AP Chem students, and welcome to topic 6.1, endothermic and exothermic processes. The learning objective for today is 6.1.a, explain the relationship between experimental observations and energy changes associated with a chemical or physical transformation. So let's get into it. So this is thermochemistry. Thermochemistry is the study of energy in the form of heat. So first of all, we're going to talk about the difference between heat and temperature. So temperature reflects the kinetic energy of the particles in a substance. So higher temperature is faster moving particles. Heat, which we often denote as Q, involves the flow of energy from an area of higher temperature to an area of lower temperature. So heat and temperature are related, but they are not the same, and that is a common misconception. So the transfer of energy in a system can be observed by measuring a change in the temperature. So the temperature does give us information about the energy flow in a system. In thermochemistry, the part of the universe, which is being focused upon is the system, and the rest of the universe is called the surroundings. Now, that is a lot of space. So universe is equal to system plus surroundings. So in thermodynamics, because the surroundings are so massive, we focus on the system. So if we look at a little diagram here, we've got the surroundings, which is everything outside of this beaker, and then the system is confined within the beaker itself. Energy that is entering the system carries a positive sign. You can see that here. That's energy entering the system. Energy that is leaving the system carries a negative sign, like that. Okay, so now let's talk about heat flow for reactions themselves. So reactions can be described as being either endothermic or exothermic. So exothermic reactions cause a decrease in the temperature of the system, which means that heat is lost to the surroundings. Now, this can be a little bit confusing for students when they're first thinking about it because it feels hot. You have to remember that you are part of these surroundings. So you are gaining the heat that's being lost by the system. The system itself is actually losing energy. Endothermic reactions cause an increase in the temperature of the system, an increase in the energy of the system, which means that heat is gained from the surroundings. Now, that will feel cold because I actually like to call cold unhot because what's happening is if you touch a container in which an endothermic reaction is happening, energy will leave your hand and flow into the system. And the loss of heat is what our body perceives as cold. So actually, it's a little bit better terminology to say hot and unhot because cold is the loss of heat. So it feels cold. You're part of the surroundings, so you lose heat to the system in that case. So that's it for an intro to endothermic and exothermic reactions. We're going to get the whole unit is going to focus around endothermic and exothermic processes. So what should you be able to do with this right now? Well, you should be able to determine if the process is endothermic or exothermic strictly based on sign. If you know that it's endothermic or exothermic, you should be able to assign the sign to that delta H. Also, this is a unit in which I think it's very helpful to actually write the positive sign. Of course, positive signs are understood, but in thermochemistry, because the positive and negative dictate a direction of the flow of energy, it is extra helpful if you write the positive. And that is it. So we'll explore endothermic and exothermic much more as we move through the unit, and I'll see you soon for topic 6.2.